A caption is available. You can access this by clicking the three dots on the bottom right corner of your screen. If you experience any issues accessing captions, please message Caitlin, who is our ghost moderator, or the bin organizer on the Zoom. Before we begin, I would like to acknowledge that today I'm joining you from the Lenape lands. We are all joining this event from places around the world. And so I invite you to take a moment to reflect on the lands you are joining from as well as the relationship of those lands to the indigenous people who have and continue to inhabitate them. So I'm Ashley Cunningham, and I am a co-founder of Black and Neuro and the current communications director, and I'm happy to welcome everyone to the seminar series. So it's my honor today to present today's speaker, Dr. Jasmine Hope. So Dr. Hope received her PhD in neuroscience from Emory University in 2022. She's currently studying the underlying neuropathophysicological mechanisms of gait control in persons with stroke, but has a background in non-human primate cognition and genetics. She's currently a postdoctoral fellow in the Department of Rehabilitation Medicine at Emory University School of Medicine and teaches at Emory College. Outside of her research, she is a community leader in the west side of Atlanta, as she serves as a neighborhood planning unit chair and a board member to her neighborhood association. As she continues her research, she also will begin teaching next year at Spelman College and has a strong interest in combining mentorship of diverse students and backgrounds. And so without further ado, Dr. Hope.
Thank you so much. Let me just get this share screen started and I will begin. And I'm from New York, but sometimes I talk really fast. So please raise your hand, put in the chat to slow down, and I will try my best. I've been in Georgia for the last 20 years of my life. So it should be fine. Should is a key word, but just let me know and I will slow down. So hello again, my name is Dr. Jasmine Hope, and today I will talk to you all about my research titled Electrical Stimulation-Based Treadmill Training Modulates Spinal Reflex Excitability in People with Stroke. Here are my objectives. If you know me or ever get to know me, I'm always singing, like always, even in lab. So because there's always a song in my head, if you guys understand some of these song references, more cool points to you. First, during this presentation, I will talk a little bit about my journey as a neuroscientist. Then I will get into the importance of getting on people's nerves. But of course, this isn't in the context of my research. How do I get on people's nerves? And then what happens after spinal reflex, after electrical-based treadmill training. And then finally, go over how this electrical-based treadmill training and the results of my study fit into the context of neurorehabilitation in general. But first, a little bit more about me, talking about my journey, since this is Black and Neuro, and I'm very interested in having a mentor and being a mentor. So a little bit about me. Here's a general timeline of my journey. Of course, as a disclaimer, to those who are just beginning their neuroscience journeys or their research paths, in no way, shape, or form is this a journey that you need to go on to get to where I am. Everybody's path is different, and the path that you take will be very different from mine. But I started school at Emory University in 2011. Of course, like many people who joined Emory, I was on the pre-med track back then, but interested in the brain because of horses. Then had the opportunity to hang out with apes. Then I started chilling out with monkeys. I took a gap year after graduating from Emory in 2015, and I wanted to continue my journey with monkeys, but get more wet lab experience under my belt. I wanted to continue research, so I began grad school in 2016, which feels like it was just yesterday. But reflecting back and doing some math, that was 8 years ago, which is a lot. I began research with primates that actually talk, so humans. So all my research was still primates, but most of it was non-human primate before I started grad school. Then I gained PhD candidacy 2 years after that. I got married in 2019, which I just want to say goes to show that even when you're getting your PhD and in academia, life still goes on. So please still live your life. Um, I was awarded NRSA Diversity F31 funding in 2019, which also goes to show that you can still live your life and have career successes. You have to have balance. Of course, in 2020, the entire world shut down, so it's not all rainbows and butterflies like Maroon 5 said. It's also compromise that moves us along. So I had to pivot the project I was funded on because I was conducting my research in a hospital setting. But there's still light at the end of the tunnel because in 2022, I graduated Laney Graduate School. Then I began my research as a postdoctoral fellow, still at Emory in January 2023. Since then, I've been outside, guys. I have been outside. I have been going to conferences, applying to fellowships, etc., because I wanted to make up for some of the conferences that I missed because of COVID. If you can't tell from my personality via the computer, I love talking. I love meeting people. So it was really great. Last year, I went to maybe too many conferences. I slowed down a little bit this year. Um, and then in 2024, just a month ago, I received the 3-year first fellowship, which will allow me to continue the research that I've been doing at Emory and also teach at Spelman College here in Atlanta, which I'm really excited about. Oh, and also, fun fact, I'm 7 months pregnant. So if I seem even more out of breath than usual, if you've met me before, it's because my diaphragm is a little squished. So please give me some grace if I feel seem like I'm running a marathon. I kind of am. So now to go into some more detail about my experiences. As I mentioned before, it all started with horses. Mind you, this wasn't my first plan. I wanted to make some money after my freshman year at Emory. Emory's very expensive. It's nice to have some extra money in your pocket. So when I went back home to Jonesboro in Clayton County, Georgia, I interviewed at Macy's at South Lake Mall and didn't get the job, which I think is super embarrassing at the time. But in hindsight, I'm really happy that I didn't because it started me on this journey of research in neuroscience. So I wanted to stay busy and I volunteered at the Calvin Center, which was down in Henry County, Georgia, which I had previous relationship with through my church. And I assisted with their hippotherapy program. So I worked with people on the spectrum and people who had Down syndrome, as well as took care of the horses during the therapeutic riding program. This experience working with animals and horses sparked my interest in how the brain worked. How were the horses able to be trained? How was it beneficial to the people riding with different abilities? So I was really curious. So when I got back to Emory after the summer, I applied to the Scholarly Inquiry and Research Emory program, also known as the SIRE program. So this program matched students with research opportunities at Emory. I was matched with Zoo Atlanta, but I was initially very hesitant to do so because Zoo Atlanta wanted more senior students, and I was just a sophomore, still not sure what I wanted to do, and I didn't think I was qualified. But I got a push from the then director of the program and still my current mentor and friend, Dr. Leah Roche. And I went on the interview, and the researchers are at Zoo Atlanta. They were happy to have me, especially with my experience with horses and my curiosity and enthusiasm about the research that they were conducting at the zoo. I learned how to program touchscreen computer experiments to test cognitive abilities in orangutans and gorillas, which is a very unique experience, and I really, really enjoyed it. And that's young Jasmine on the left. I still had a perm in my hair. This is a very long time ago. And I was showing Satu, the orangutan, on the left, his results from a handedness task study that I was doing. And on the right is Madhu. She's working on one of our computer rigs. Through the experience at the zoo, I discovered that I wanted more. So I applied to the Neuroscience Education Training Program or Network Program, which was a T32 fellowship for 2 years of research funding and professional development. This allowed me to continue my research at Zoo Atlanta and join a lab at Emory National Primate Research Center, where I began to work with rhesus monkeys, so still with non-human primates. And the summer between my junior and senior year at Emory College, I was able to conduct research at UC San Diego with juvenile Carmen marmosets to study social cue awareness and communication. My senior year at Emory, I completed my honors thesis with highest honors on representational momentum in non-human primates. And here are some of the monkeys I worked with. But after I graduated, I still was not sure what path I wanted to take. Did I want to go to med school? Did I want to get a PhD? I wasn't sure. I was also interested in vet school at that time because of all my animal experience. I also wanted to gain more wet lab experience and research skills because a lot of the research I conducted was more behavioral, and I wanted to be more attractive to whatever program I was going to go to and have some wet lab experience under my belt. So I swear to God, cold emailed over 100 PIs in the Emory and greater Atlanta area. So Georgia State, Georgia Tech, et cetera, and landed a job as a research specialist in a lab that initially told me no and asked me to just, no, not right now, but maybe ask back later. We're still thinking about our funding. So just because the door is closed doesn't mean it's going to stay closed forever. And I'm really happy that I had this experience because I was able to study Huntington and Alzheimer's disease in transgenic models of rhesus monkeys and mice. This was a humans genetics lab, so I got to do a lot of wet lab experience while still using the skills that I gained when I was undergrad with monkey behavior and training. So I did PCRs, Westerns, blood processing, semen processing, stereotaxic surgeries, microscopes, IVF in monkeys, ultrasounds, training monkeys for blood draws, mice breeding. I will never use most of these skills ever again because the research I do now is very different. However, this was a very meaningful experience for me because a lot of the research I do is still neuroscience and I deal with rehab. So when I read papers that are more from the basic sciences, I actually can understand now what the techniques were used. I'm not as confused anymore when I read about them. So this was still a very valuable experience. Plus, I learned what I do like and what I don't like. So don't be afraid to go out and do something very different than what you're used to because it's still a very valuable experience. But one of the things that I did discover is that from this lab experience, I was a research specialist. So I was just carrying out the experiments of somebody else. I wasn't developing ideas. I wasn't in the room when they were trying to troubleshoot problems. I wasn't asking the questions. I was just doing. So I really missed that component of research from when I was an undergrad. I was able to actually develop projects. So from this and this desire, I decided that I wanted to go ahead and get my PhD. So after being accepted into a few neuroscience programs throughout the East Coast, I decided to stick with Emory because of the research opportunities and support that I had here. After doing my 3 rotations in my first year at Emory in the PhD neuroscience program, I joined the whole spinal cord injury lab under the direction of Dr. Adele Field-Fouté. I like the rehab component, thinking back to my experience with the hippotherapy with horses and even working with transgenic and Alzheimer's transgenic models of monkeys and mice. This was all kind of coming full circle for me with the rehabilitation. And I was still able to work with primates, they just happened to talk. Plus, this was a very fun lab environment. As you can see, I'm just kind of hanging around, testing things out. This is me without a perm, but transitioning to a more natural hairstyle. So as you can see, it was a very close-knit environment, a lot of great people. I worked with physical therapists, occupational therapists, as well as engineers. So it was a very helpful, valuable experience for me and my PhD skills. And I like to have fun and socialize. And I'm also very competitive. The field day champions that was us until I left. So I'm just saying that I had a very important uh, I was a very important team member when it came to being competitive. So back to research, I really went full circle with my focus on rehabilitation. I worked with people who had spinal cord injuries and focused on improving their walking ability through ankle control. So as you can see in this video, this person has something known as spastic gait due to hyperexcitability in their ankle muscles, which just means that their reflexes are so sensitive that any input that happens, it overreacts and overshoots. So they have clonic activity, which is that shaking that you can see in their leg muscles and their ankles. And they also have a hard time picking their foot up to get over ground. So this makes it very unsafe for walking, makes walking very inefficient and slower. So this is something that I focused most of my PhD attention on. Of course, I was a part of other projects, but my own project, I was focused on ankle control and how ankle control was related to walking and walking safely. So my research title is Neuromodulation of Ankle Muscles in Persons with Spinal Cord Injury. In my research, I focus on interventions that would neuromodulate the ankle muscles using non-invasive techniques. So one of the techniques that I used was called whole body vibration. So this was a lot of afferent input using whole body vibration that would affect not just the local spinal reflexes, but also hopefully the cortical spinal tract. So from the brain, spinal cord to the ankle muscles. So I would use other non-invasive techniques to probe the system of the spinal reflexes, as well as transcranial magnetic stimulation to probe the cortical spinal tract. So again, brain, spinal cord to the ankle muscles of interest. I was able to complete my dissertation focus on ankle control. So this is a picture for me for my defense. I always think this picture is funny. My little brother Matthew took it because I think that I look exactly like Amarion doing that viral dance move. I think it's hilarious. Most of the people in my lab didn't know what I was talking about, so I had to add the picture in here for reference, and I'm gonna keep it here for future talks. And I graduated from Emory-Laney Graduate School in December 2022. From there, I was able to start my postdoctoral fellowship in Dr. Kessar's lab, focusing still on ankle control, but instead of in people with spinal cord injury, I was focused now on people who had stroke. And again, life doesn't stop. I have been married now for going on 5 years. Graduated, and now I'm 3 months away from meeting my son. So I'm really excited to continue the research path that I'm on as a first fellow and meet my baby and balance out life and research. But with all of that said, I've been talking a lot, like a lot, like I am a little out of breath. So to give myself a little break and to keep you all engaged, I had this interaction break. So before I was going to utilize Zoom reactions, but some of the Zoom reactions I don't see, so we could just utilize the chat. So utilizing the chat or Zoom reactions, whichever. My baby will be born in late July, but he's right on the cusp of Cancer and Leo season. So what do you guys think his zodiac sign will be? And of course, you can always follow up with me to figure out what it's going to be in about 3 months. So using the reactions of laughing emoji for Cancer, because they're emotional, right? And the heart emoji for Leo, because they seem a little guarded, but they have big hearts. What do you guys predict my baby will be? And I'll look at the chat. And I'm going to give it a second because I need to drink some water. So utilizing the chat, utilizing the reactions, any predictions, any. Does anyone think anything? I'm very curious. And of course, I could just look online as well. Team Leo. Good. I have nothing against, I promise I have nothing against cancers. It's just my family, we have a lot of cancers, and I think it would be nice if we balance it out a little bit. My husband, again, he's a Scorpio, I'm a Gemini, so I think it would be fun to have a Leo in the household. So thank you for participating in my interaction break. I have a few more to go, so. Now let's get into some science. Again, my project is titled Electrical Stimulation-Based Treadmill Training Modulates Spinal Reflex Excitability in People with Stroke. And of course, this is going to have to do with ankles because apparently I'm obsessed with ankles, and this is what I am as a neuroscientist. So, stroke adversely impacts walking ability and functional independence of survivors. And again, because of who I am, I'm focused on ankles. So hyperexcitability, specifically in the ankles of the spinal reflex circuits, measured using something called Hoffman's reflex or H reflex, and I'll refer back to that throughout this talk, is associated with spasticity. So uncontrollable movements, abnormal muscle coordination, and may also contribute to post-stroke gait deficits. So again, I care about walking. Ankles are important for walking. What happens after spinal cord injury and stroke is that you have these hyperreactive reflexes in the ankle muscles that make it hard to walk. So we have something that we use in our lab, an intervention known as fast FES training. So what this is functional electrical stimulation, which pairs fast walking on the treadmill with the timing of stimulating the appropriate muscles during gait. So for example, when somebody's walking, when you're bringing your foot over ground, you want your front muscles in your leg to be activated. But when you're pushing off, you want your back muscles to be activated. And people with stroke and spinal cord injury, this is harder to do. So we add electrical stimulation at the right timing of gait in order to help assist the movement so they can walk over ground. And we train them to do this. So we're having the electrical stimulation on during fast walking on the treadmill. But what we don't know from using this type of intervention is how the changes in the underlying neurological processes can affect spinal circuit plasticity. So does this intervention of using electrical stimulation at the right timing during treadmill walking affect the ankles? And does it specifically affect the spinal reflexes that change after stroke? So the objective of the study is to compare changes in spinal reflex excitability induced by fast, so just walking fast on a treadmill versus walking fast on a treadmill with functional electrical stimulation, and to evaluate associations of spinal reflex excitability, again, which changes after stroke, with functionally relevant gait metrics in persons with stroke. So not only are we focused on is there something changing in the spinal reflex circuit and the excitability in your neurophysiology, but does that change have any association with your ability to walk better? Another interaction break, because as you can hear, I need to breathe for a second. So again, you can use the chat feature, you can use the reactions, etc. This just gives me a moment to take a break and for you guys to stay engaged. So pop quiz, can reflexes change? Yes or no? Very simple this time. And I can't see the reactions, but I can see that you guys can see the reactions. So you could just let me know what people are saying, yes or no. Majority, yes. Yes. So if you've been paying attention, reflexes can definitely change. They change after you have upper motor neuron damage from spinal cord injury or stroke. Whether these changes are good or bad or not, we can talk about later on in this talk. But thank you for paying attention, guys. So for this study, the general methodology is as follows. So this is a repeated measures crossover. So everybody that was started in one group eventually got into the other group, and we're just comparing how the intervention is of fast walking versus fast walking with functional electrical stimulation is in the same group of people. So we had 12 participants total. This is very preliminary pilot study with people with chronic stroke. So meaning that they had stroke at least 6 months ago. So they received 3 sessions of fast FES, so adding that functional electrical stimulation, and 3 sessions of fast in a randomized order. We also measured Hoffman reflexes, so reflexes, their spinal circuitry. was evaluated in response to peripheral nerve stimulation of the posterior tibial nerve. And I'll go over what that means in the next few slides at pre and post 3 training sessions. So before and after, we're looking at their neurophysiological changes in the spinal reflex. And from those measures that we're getting from the spinal reflex, we took a ratio, something called Hmax Mmax ratio, that gives us a way to measure how excitable the reflexes are. And we use a recruitment curve to do that. And then finally, we evaluated the associations between the spinal reflex that we're seeing and gait biomechanics, peak ankle moment, anterior ground reaction force, gait functions such as overground speed, walking speed, timed up and go, because it's not just important to see a change in your neurophys and the electrophysiology measures that we're using, but is it actually associated with something that we can see behavior-wise and improvements in walking ability? So for functional electrical stimulation, this is the intervention that we're using. We're putting electrical stimulation pads placed on the shin and calf muscles, so the front and the back of the legs. The muscles over the shin or tibialis anterior is responsible for dorsiflexion. So that's bringing your foot up towards the ceiling, which brings your toes up over the ground during the forward the forward proponent of walking. So bringing your leg up so you're not tripping. The calf muscles or your gastrocnemius and soleus are responsible for plantar flexion. So that's when you're like pushing down on a gas pedal in your car. So that's really important for forward propelling during walking. The stimulation is turned on for each muscle during the appropriate timing of gait. So I'm not just slapping on electrical stimulation pads and keeping them on, which some people do. This is functional. So functional means that during walking, the appropriate muscle is on at the appropriate time. So during swing phase, when I want the front muscles to be activated, that's when the electrical stim pad for that is activated. And for late stance, when you're trying to push off, we have the back muscles activated using that electrical stimulation. So for our fast FES, that's the functional electrical stimulation, they're walking fast on the treadmill for 6 minutes with the functional electrical stimulation on and off every other minute. After each set of 6 minutes, participants take a 5-minute break. We don't want them to be too fatigued. And this pattern is repeated for a total of 5 sets of walks. And then we measure their overground walking speed off of the treadmill. And then for the fast training sessions, this is just the same thing, fast treadmill training, but we're not using any functional electrical stimulation. So the outcomes of interest, again, spinal reflex excitability. We're looking at something called Hmax versus Mmax. And we also, for the study, looked at slopes, but for the purpose of the talk, we'll just focus on Hmax, Mmax. So we use something called the Hoffman reflex. So using a stimulation pad over the back of the knee. This is where your tibial nerve is, which is important for plantar flexioning. So is the soleus muscle, which again is really important for pushing off during gait. We're using EMG feedback so we understand, one, that we don't have too much noise. Noise is a bane of existence for anybody who's done electrophysiology before. So I'm monitoring the noise, and then when you stimulate at a low intensity, you get the equivalent of a spinal stretch reflex. So if you know when you go to the doctor and they hit you with the knee, then you get the movement of your knee, you're kicking out. This is the same thing, but we're bypassing having to hit people with hammers all the time. We're just using electricity to bypass that. So from that, we can get a measure and probe the spinal reflex excitability. We're also interested in gait biomechanics, so anterior ground reaction force, how much are they pushing off? Peak ankle moment, where's the ankle at when they are doing that push off? Gait function, so overground walking speed, how fast are they walking because of this intervention? And then timed up and go, can they stand up, walk, and then sit back down? That's very functional to do for anyone. So we're looking at these 3 components as our outcomes of interest after the intervention. So back to Hoffman H reflex, because not everybody is familiar with this. So I just want to make sure that in order for you guys to understand my results, we really have to understand the Hoffman H reflex. So I'm going to show you some representative data, but again, back to the doctor. I think I don't know the last time I did it. It's probably when I was a little kid. I test my reflexes all the time because of the lab I'm in, but I don't think I would if I wasn't in my lab. But the last time I tested my reflexes, I was definitely a kid, and we used the hammer on my knee, and I kicked out, and they're like, okay, you have reflexes, great. So, same thing, but we have stimulation in the back of the leg, so peripheral nerve stimulation, targeting the tibial nerve, soleus H reflex, so that spinal stretch reflex. So it goes up to the spinal cord, right back down to the muscle. You get a twitch, and we read this out using sensors over the muscle of interest, which happens to be the soleus muscle, again, which is very important for plantar flexing or just pushing that gas pedal. So from that, we get an M wave. So that's the direct motor response from the stimulation, the tibial nerve back down to the muscle. But what we're really interested in is the reflex. So going up to the spinal cord and coming back down, it takes a little longer to come to the system. So it's later in the response. And from this, we start at a low intensity and gradually increase, and we get something called an HM curve. So from this HM curve, we can, in the green is the H and red is the values for the M. We're able to monitor the excitability of the spinal reflex. Again, I've been talking a lot, so guess what? Time for interaction break. Keep you guys engaged and give me a break so I can breathe because my poor diaphragm. So I'm curious to see what you all predict the results will be now that I've talked about all this. How do you think that fast FES, so again, that's with adding the functional electrical stimulation during fast treadmill walking, will impact spinal reflex excitability? You think you're going to see an increase, a decrease, or no change? So this is just a fun time for you guys to predict the results, and then I'll tell you what they are. So, ooh. I think it'll go up after training. Okay, increase. Interesting, because I thought it was going to decrease, but it didn't. So you guys are actually right. So again, HM max ratio, this is telling me the excitability of the system for the spinal reflexes. After the 3 sessions that we do for fast FES training, we have an increase. So here on the y-axis is HM max ratio. So the higher it is, the more spinal excitability. This is pre 3 sessions and post 3 sessions of fast walking. So this is without adding the electrical stimulation on. There's no difference between the two pre and post. However, for fast FES, when we add that functional electrical stimulation, you do see an increase in spinal reflex excitability after the 3 sessions. So there is an increase. You guys are right. You might as well write this paper for me because I need to write this up before my babies do. So thank you guys. I will add you guys as co-authors. I'm just kidding. And then between FAST and FES, there actually is not that much of a difference. But mind you, this is still just 12 participants. This is a very preliminary study. We were also able to look at a single session effect, so acute effect pre-post, right before and right after doing the treadmill training and doing treadmill training with the functional electrical stimulation in 9 participants. So interestingly, after FAST, where we don't use functional electrical stimulation, there's a decrease in spinal reflex excitability. So again, 1 session of just walking on a treadmill, there's a decrease in spinal reflex excitability. But going back to 3 sessions of adding in the functional electrical stimulation, there's an increase. So there is modulation happening, and I'm really curious to look back at my results and figure out why is this happening. But of course, we need to understand in the context of function, what does this mean? So HM max ratio, spinal reflex excitability at baseline, before we do any intervention, how is this associated to some of the functional outcomes? So baseline HM max ratio and baseline anterior ground reaction force, how much you're pushing off. As you increase spinal reflex excitability here on the x-axis, you're decreasing the anterior ground reaction force, which is not necessarily, that's not really a good thing. You actually want a higher anterior ground reaction force. For spinal reflex excitability and ankle moment, same thing. as you increase spinal reflex excitability, there is a significant decrease in ankle moment, which is also not good. For baseline H and baseline OG, overground walking speed, increase in spinal reflex excitability, you decrease speed. So people are slower when they have higher spinal reflex excitability. And again, after a stroke, usually you do have that increase in spinal reflex excitability and a decrease in function. And here, to orient you for timed up and go, the higher amount of time it takes for timed up and go, the lower your functionality. So an increase in HM max ratio increases the amount of time it takes for timed up and go. So for all these measures that we're taking, an increase in spinal reflex excitability or higher spinal reflex excitability at baseline is associated with lower function. So in conclusion, fast FES, so treadmill walking and treadmill walking with the functional electrical stimulation, may differ in their effects on spinal reflex excitability. 3 sessions of fast FES, but not fast, increase spinal excitability, but acute effects of 1 training session show depression or decrease in spinal reflex excitability after fast, but not fast FES. So they're doing 2 different things. One's increasing and one's decreasing. What we need to figure out is the context of, is this increase in spinal excitability actually associated with a change in function? So after 3 sessions, we have some of the preliminary data, and none of it's associated with anything. That's only 12 participants. But we do have an overall study that we're doing now where we're doing 12 sessions instead of just 3. And I'm curious to see how these changes will reflect in that study versus this preliminary one. So these are my results. And of course, with me talking so much, we're doing another interaction break. So now that we went over these results, is it a good or bad thing that spinal excitability increased after adding in functional electrical stimulation for 3 sessions? So we got good, do you have bad, or do you have neither? So do you think this increase in spinal excitability is a good thing, bad thing, or neither when it comes to function? Give you guys a few more moments for your predictions. Good, bad, neither. Well, predictions, opinions, because I still am figuring this out. Any of my panelists, can you guys tell me what they're saying so far? Lots of thumbs up. Okay, so good. Well, so not sure, actually. So this is something I'm still trying to figure out. Again, this is very preliminary, which is exciting about research. This is why I do research, because there's a lot of unanswered questions. And a lot of these things, such as functional electrical stimulations, already being used in clinical settings. Like when I was at Shepherd Center, when I was doing my PhD at Emory, there's already stimulation pads always being used on people with spinal cord injury, strokes, TBI in a functional way, but we're not sure if it's changing spinal reflex excitability and if that change is a good thing. So there's this big push right now in rehab medicine where we're trying to be very specific to each participant. I don't think there's any one size fits all when it comes to rehabilitation, and that's what we're finding out, because everybody usually has a different baseline value. And does that baseline value tell us anything about what would work better for them intervention-wise? For example, is there a scenario where it's better for some people to only have treadmill training without functional electrical stimulation? And is there a scenario where functional electrical stimulation is actually helpful for some people? So we have some future directions. So I want to determine the effect of greater training dosage. For example, this study, we're only doing 3 sessions. As I was saying before, we have a 12-session study that we're doing right now in our lab for our R01. So is it just a training dosage thing? Is it functional electrical stimulation is great, but you just need to do 12 sessions of it? Implication of spinal reflex plasticity on fast and fast FES gait training on therapeutic response. Is there a differential response when you do fast versus fast FES? And what makes that change? Is it the individual? Is it dosage? Is there something else that we're not thinking of? Is it spasticity? Who knows? But we're going to find out. And examining effects of altered timing of functional electrical stimulation parameters on spinal reflex excitability. So again, functional electrical stimulation is very timing dependent. We're making sure that the muscle is activated at the right time, but there's ways that you can alter those parameters, and can altering those parameters have any effect on your results? And finally, identifying the impact of spasticity and other biomarkers on the effects of fast and fast FES. Because again, no one stroke is the same, no one individual is the same. So trying to understand how somebody who's coming in to receive rehabilitation and using something like spinal reflex excitability as a biomarker to predict who is going to be responsive to what therapy will be very important moving forward for physical therapists to treat their patients. So with that, I want to give my acknowledgments. So I'd like to thank the members of the CASAR Lab and all the research participants for volunteering their time in the study. And the funding for this study is from an NICHD grant, and I am myself am an Emory First Fellow. So with that, I will entertain any questions, and thank you guys for your time and participating on Zoom and on YouTube.
That was a phenomenal talk, Dr. Hope. I really, really enjoyed the interaction breaks. I had never seen that in a talk, and it's so
I'm
good.
trying to be unique. I love
Yeah,
interacting, so I appreciate it. I'm glad that it actually went well because I was afraid to see what would happen. So I'm gonna keep using things like this in future talks. And please feel free to borrow my interaction breaks idea, because any way to make things more engaging with the audience, I'm all for.
it was phenomenal. I'm gonna tell everyone I know about that that idea. So we
Mhm.
do have one question. So far, it's what was the biggest change from going from non-human primate to a human model?
Oh my gosh. So the biggest change for me, the biggest change for me was that the availability of participants, right? So when I worked with non-human primate models, they were always there. So it was easier to get data collections done. Whereas with scheduling people to come in, will they actually come in? Will they stay in the study? Is very different. But what I do like about doing clinical research is that it's way more applicable. So the things that we were doing with non-human primates was to give us more information about what we can do in humans. But if I directly do things with humans, it's super applicable. You can use it in the clinic immediately. However, you can't be as invasive with humans. And even with the non-human primates, there's levels to it, right? Like with the mouse models, I was able to do surgeries, but I wasn't doing those same surgeries in orangutans or gorillas because it was always protected contact. We're very much like, it was more voluntary. Like we put the computer in front of them. If they worked on it, cool. If not, cool. And the monkeys, we were able to do surgeries. So there was levels to what you can ask because of what you're allowed to do. So I hope that answered your question.
No, yeah, that was really helpful. I
Mhm.
actually had a question. Do you see any like age-related differences in your human population that you're looking at? Because you were
Oh,
talking about how like having a baseline difference
mhm,
can have an impact. So like I don't know, I think about my reflexes versus my grandmother's reflexes, like
mhm.
they're a little slower. So like, do you see any differences
Oh
there?
yeah, there's definitely research that shows that there's age differences in reflexes. And in a lot of the studies that we do in lab, we focus on people with stroke, older adults, and young adults because of those differences. Of course, in this study, it was only 12 participants, so I can't really divvy out age. Most of them were the same and similar age category. But in other research that we've done in lab, we do see those differences, and we try to account for those by making sure we have a stroke group, older adult group, as well as a young adult group. That was a great question. Because reflexes change, as we were saying in one of the interaction breaks.
Okay, great. Yeah, so someone on YouTube was like very touched by your talk and said that they have a spinal cord injury and when they don't have electrical stimulation to their spine, um, they like have noticed like they feel pain um, and like we're just like very like touched by your slide and like could personally relate to some of the work you were doing.
Oh, thank you. I appreciate that.
Do we have any more questions from the audience?
And if we don't, again, my email I put on the first slide, jhope@emory.edu, and I could put it in the chat too. Um, I'm happy to ask any questions if they come up later. If anybody's interested in just talking to me about more of like my research experience, or if anybody wants to mentor me, like I love mentors. And if anybody's interested in me mentoring them, like please, please, please reach out. As you can see, I'm a talker though. So if just let me know if I'm doing too much.
Okay, I checked on the YouTube. It seems like we've addressed all questions and yeah, we just Black and Neuro really wants to thank you for your time and this phenomenal talk. I personally really appreciate like the way that you presented and it's so clear, especially as someone who like I work in mice, so don't like understand a lot of these like reflex human things.
Mhm.
But you explained everything so clearly.
Thank you. I appreciate it.
So thank you all for attending, and hopefully we'll see you all in our next seminar series.
Thank you, everyone. Thanks for having me.